Welcome to part 2 of the No-Rise Analysis Training video series, provided by the Kansas Department of Agriculture Division of Water Resources. I am Ben Ruffenau, and I will be guiding you through this training. In this video, we're going to cover how to get the current effective model. We're going to explain what a duplicate effective model is and when these are needed. We'll explain what a corrected effective model is and when those are needed. And we'll cover the path to get to the existing conditions model. So this is a flowchart provided in the FEMA MT2 request guidance. This is meant for completing a new modeling for a LOMAR, but the process is largely the same for a no-rise analysis. The first step in this process is to get a hold of the current effective model. The easiest way to get a hold of the current effective model is through the Flood Risk Study Engineering Library that's available through FEMA. If you get on the FEMA website and find the Flood Risk Study Engineering Library, you can run a search for the community you are working in, and it'll bring up any of the previous projects that have been uploaded for that community. If you need more information on using the Flood Risk Study Engineering Library, you can find it in the Mapping Information Platform or MIP guidance. You can also request the current effective modeling through KDA's Base Flood Elevation portal. KDA can help you find modeling that may not be available or just isn't easy to find on the Flood Risk Study Engineering Library to make sure that you have the correct current effective modeling. If the current effective maps in the area you are working are still paper maps, then you're probably not going to be able to get a hold of the effective model. This is likely an old HEC2 model or similar, and even if it is available, it's just going to be a PDF, just like the one shown on the screen here. Even if the current effective mapping is digital, sometimes the modeling was just carried forward from the old paper map studies and was not updated. You can tell if this was the case by looking in the FIS. The table on the top there is from an older FIS, and you can see just at the bottom of that table there's an asterisk, means that the streams were not restudied as part of the current countywide FIS redelineation streams. So those 3 asterisk streams on the top of the table were not actually restudied, are just carried forward from the paper map. So those will probably not have modeling available, whereas the bottom 3 models will have new modeling available. The bottom table is from a newer FIS, where the table actually will tell you if they know what the hydraulic model was used for the study. So you can see there, some of them just say unknown, that means it's probably not available, and some of them say HEC2 model was used, and so that also probably will not be available, or will only be available as the PDF shown in the previous slide. If the effective model is not available, or all you have is the PDF version of an old model, then we can just skip right on ahead to generating a new existing conditions model. That being said, you will want to check with KDA on their ongoing mapping projects that are currently in development. It may be that somebody has already generated the current existing conditions model that you need. You can check on the ongoing projects at KDA through their website, and if you go through Division of Water Resources, Water Structures, Floodplain Management, Mapping Projects, you can find a list of the current ongoing projects. If you look at the screenshot there, all the counties that are in blue are the counties that have current ongoing projects. So there are a lot of projects in a large portion of the state that could be ongoing at any given time. You will want to check with KDA even if the effective modeling is available for your study area. It may be that there's an ongoing study in your study area, and the effective modeling will be replaced over the next few years. You don't want to be in a situation where you go through a bunch of work to remove a structure from the floodway, only to find out in a few years it gets put right back in the floodway. So if there is an ongoing study in the area you're studying, you can contact KDA to get a hold of the new proposed modeling. And it may be a case where you need to do the no-rise study on both the effective modeling and the new modeling. Or it may be the case where you just wait for the new modeling to go effective and you worry about your project then. If the current effective model is available and there aren't plans to replace that with updated modeling soon, then that effective model needs to be used as the base model for your study. You should not be changing the model to a different modeling format. You should not be using a different modeling software unless you have a good reason to show that this needs to be done. And if there is a good reason to show that needs to be done, then you probably need to be doing a LOMAR instead of a no-rise analysis. The basis for this comes from 44 CFR 65.6A8. And this says, unless the basis of the request is the use of an alternative hydraulic methodology, which would mean you're doing a LOMAR, or the requester can demonstrate that the data of the original hydraulic computer model is unavailable or its use is inappropriate, which would be the case of the old HEC2 models on the paper maps, then the analysis shall be made using the same hydraulic computer model used to develop the base flood elevations shown on the effective flood insurance rate map and updated to show present conditions in the floodplain. Once we have our effective model, the next step is to create the duplicate effective model. A duplicate effective model is just a copy of the effective model ran on the new modeler's machine to reproduce the effective results. The reason for this is just to make sure that we have the correct model data and that we have the actual model that was used to create the effective mapping. This is required if the effective model is available. For 1D models, you can check that your duplicate effective model matches the effective model just by checking the cross-section elevations that are in the database, or you can use the FIS. So the floodway data tables will have the regulatory elevations listed for all the lettered cross-sections, so you can check those against your model. And you can also check the flows in the flow file against the summary of discharges table in the FIS. If your current effective modeling is 2D, it gets a little trickier to check that you have the correct model. You can check against the summary of discharges table in the FIS just like 1D, but in 2D you'll have to go into the hydrographs. So hopefully there is a reference line or a 2D storage area connection line at the location of each of the FIS points, and you can check the peak flow in that hydrograph matches with the flow listed in the FIS. It is important to note that these flows will likely be rounded, so they won't match exactly. You can also check the BFEs and cross sections in the database against the water surface contours in the modeling. In HEC-RAS, you can go into your RAS mapper and you can tell it to display the contours of your water surface output grid. In this example shown, you can see these contoured water surface elevations. You can see right here, this water surface elevation contour matches up with this cross-section X in the effective mapping. And you can check that with all these other cross sections as well. It is important to note that these may not match exactly because there is a lot of cleanup done during the plotting process to establish the mapping extent of the rivering flooding, And you can also see that a lot of those contours are removed from the effective mapping. So all those flows coming in from the street flow there on the sides, all that extra ponding going on out in the community is all cleaned up, and only the riverine flooding is shown on the effective mapping. So this can get a little confusing to verify. If the effective modeling does not match the duplicate effective model, make sure you check with KDA to make sure that you have the correct effective model, and also make sure that you didn't miss any LOMARs that have been incorporated since the modeling went effective, and you need to use the LOMAR model as your base model. Once we establish that the duplicate effective model matches the effective mapping, then we can move on to the corrected effective model. Now, the corrected effective model is a copy of the duplicate effective model that has corrections of any technical errors that were present in the effective model. Now, this is only needed if there are some significant technical errors in the effective model. This model should represent conditions at the time the model went effective. So we're not talking about making changes that have occurred in the floodplain since the modeling went effective. We're looking for just things that were actually wrong at the time it went effective. The corrected effective model can also be used to just update the modeling software to a newer version. So if updating to a newer version of the modeling software actually changes the results, then the corrected effective model is a way that you can show that change. If a significant issue is found in the effective modeling, then you should get in contact with KDA to inform them of the issue. It may be that the issue has already been addressed in some way, or it may be that a mapping update is needed to correct this issue. Once we've established that the duplicate effective model matches the effective mapping and that there are no significant technical issues in the modeling, then we can move on to creating our existing conditions model or pre-project conditions model. This is the model where we make changes to represent the current conditions of the floodplain. So any changes that have happened since the modeling went effective should be represented in this model, including any previous LOMARs that have been completed. Additional details should be added to the existing conditions model, sufficient so that the proposed changes are well represented in the model, even though those changes will not be made to this model. In a 1D model, this might mean that we need to add additional cross-sections to the model. Adding this additional detail to the existing conditions model ensures that the existing conditions model and the proposed conditions model will have duplicate data points so that we can easily compare water surface elevations across these cross-sections. In a 2D model, this may mean we need to add additional mesh refinements and break lines to ensure that the proposed changes are well represented in the mesh. Just like the 1D model, this ensures that when we compare the existing conditions model and the proposed conditions model, we can compare the differences in water surface elevations in each cell. The last thing I'll talk about for this video is how all these different models that we've generated should be compared. So this is a flow chart from the current FEMA guidance for floodway analysis and mapping, and it gives you an idea of how these different models relate to each other. So we created the duplicate effective model, and it should be compared back to the effective model to make sure that we're using the correct starting model. The corrective effective model is created to fix any technical issues or update software versions, and this is compared back to the duplicate effective model to see how big those changes are. And then we create the existing conditions model, which shows any changes that have been made to the floodplain since the effective model was created. And this is compared back to the duplicate effective model to see if there's any unpermitted changes that have occurred in the floodplain. Hopefully, all of these models actually end up showing the same results. And then, of course, once we generate our proposed conditions model, we compare that back to our existing conditions model to show that we have no rise in our project area. We've covered a lot of ground in this video, so I'll try to summarize the most important points here. So you can download the current effective models from the MIP through the Flood Risk Study Engineering Library. If the effective model is not available or is an outdated model, the process can start with a new existing conditions or pre-project model. If an effective model is available, it should be used as the base model unless you have a good reason that this model is inappropriate for the study area. A duplicate effective model should be generated by running the current effective model to check that the results match the effective mapping, and this duplicate effective model is required for all no-rise analysis. A corrected effective model can be created to fix any technical issues with the model or to update the modeling software to the current version. The corrected effective model should reflect the area at the time the mapping went effective and should not have any changes that have occurred in the floodplain since the effective date. The existing conditions model should represent current conditions with any changes applied since the effective date. The existing conditions model should include additional detail such as cross sections in a 1D model or mesh refinements in a 2D model so that it properly represents the proposed changes, even though the proposed changes are not applied to the existing conditions model. Matching cross sections and mesh allows for easy comparison between the existing conditions and proposed conditions model. If you have any questions or are looking for more information on anything that was shown in this video, you can contact the Kansas Department of Agriculture Division of Water Resources Water Structures Program at the phone number or email address shown here. You can also go on the website to find more contact information or just find more general information about this subject.